All right, we should be live now. Welcome everyone. Thanks to those of you that have joined us. With me, I've got Jason Weber and Dan Mayo. Jason and myself are joining you from South Africa, and then Dan is joining us from Melbourne, Australia. So for us, it's 9 p.m. at night, and for Dan, it's 6 a.m. in the morning. So thanks, Dan. Yeah, thanks so much.
It's always good to have a reason to get up early.
Yeah, thanks so much for joining us so early in the morning. This was the only time that we could actually find. We were just talking now, and Jason has a 4-week-old and Dan has an 11-week-old in the house. So sleep. Well, I've got a 3-year-old toddler, so sleep is not something that we're used to.
It's a luxury, yeah.
Yeah. Okay, Dan, maybe Jason and I have introduced ourselves, or we introduced ourselves in the previous session. Maybe you can just quickly introduce yourself.
Sure.
Yeah.
So for you viewers who don't know me, I guess I'm one of the very original generation of sort of competitive financial modeling. I came to this, the very first year Model Off ran in 2012. I heard about it. I competed because I was curious what a financial modeling competition would look like. I came second in the world that year. And then I joined the organizing committee for the next year because the organizers were from Australia and I wanted to get more involved. And so I was involved in Model Off from its second year in 2013 until it ended, and sort of led the question design team for many years and, administered the live finals. So a lot of the top performers from Financial Modeling World Cup I've met before at the various finals in Model Off over the years. And yeah, I'm feeling a bit old and slow now. The speed is important in these competitions to do well. But I kind of just seem to be hanging around the top 10 in the FMWC, and I don't think I'm ever going to get to a top 3 place, but I'll see what I can do. I'm due to come up against Diarmid in round 4 of this competition, so hopefully he'll have a bad day and I can sneak past him.
Great. Yeah, he's been having good days from what I've seen on the live broadcasts and the live feeds that he's been recording. And I mean, I looked at my performance in the past weekend, and I felt like if I had to live record that, I would never be able to release it because I did some really embarrassing things while I'm under pressure and while I'm rushing things. But yeah,
I guess hard under pressure. I make a lot of little mistakes, off by 1 errors and things like this. So
yeah. Yeah, and if you just take your time, you think about a case, and you have time, you don't have pressure. It comes more naturally.
Yeah.
But that's the nice thing about this competition is being able to see how guys can in a live competition under pressure can perform and can rip out incredible formulas. I've actually watched Bo, who goes by the handle of Excel Wizard on YouTube, and he's been doing these speed runs, and he showed actually most of these he showed how he made or how he performed in a speed run. But I mean, under pressure, you won't be able to do it like that.
Yeah, because a speed run you can practice it, get it down. But it's you're absolutely right, and it's just you can sometimes see how to do it, but you make one syntax error in your formula and it takes you too long to debug, and game over.
Yeah, so let's get into the cases. We had 4 cases over the 2 sessions. We had a morning session, which was the Asia Pacific session, and in that session we had the Mays and Othello, and Jason actually participated in that session. And then the afternoon session or the evening session for us, for the rest of the world, and I think that was morning for you as well, Dan.
It was. I actually requested to be in the rest of the world session only because I was busy when the Asia Pacific session would have been running, and so I said, let me do in the middle of the night, and then I ended up on the live stream for that as well. So yeah, that was a 3 a.m. to 4 a.m. job for me at the time.
Crazy. So yeah, those two cases were the social network and passing notes. So we're going to be jumping into them now. We're going to be spending some time on them. We're not going to be doing them end to end because there's not enough time. We just have an hour, but we wanted to talk about strategy, how you can actually solve this, and what would be a good strategy in solving it from what we've put together. So I'm just going to share my screen quickly, and we'll get into the maze one first. If I just jump to maze, this one was one from maybe just click on share. This one was one from Joseph Palasok, and essentially there's a mad scientist and there's mice running around trying to solve a maze, and the maze actually looks like the FMWC logo. Now, I've already tempted this, but in essence, one of the first tips that I have was I saw that Bo actually went and he filled all of the white blocks with ones. So you could actually just go and use a find and replace and go find format and choose your format from a cell. But before you do that, remove your borders, because once there's borders, all the cells are not necessarily the exact same format. And then you replace those with one. Go and select your cells and then go and replace all. And that actually replaces all of those similar cells with a one. And then, then you can refer to it as an array. So what I also did was I built with a dynamic array. I just built from the actual columns and rows. I rebuilt each one of the cell references, because initially when I did this the first time, I actually built it from cells. I see that I've broken something now in what I've just showed. But
yeah, you put the ones in and they were blank before.
Cells, I think. But anyway, so yeah, I made some references, and then the first question asked you to actually build your cell. If your cell, let me just zoom in a little bit. If your cell was actually like B10, then you'd have the number 10 from that, and then your column reference would be 2. And you'd actually multiply the number by 10 plus 2. And rebuilding this, there's various ways of doing it. Initially, I just used a left and a right. Yeah, a left and a right. And then later on, I actually built a little lookup table, and I just went character sequence from the character from 65 for 10. Sorry, did you want to jump in there?
Oh, I was just going to say, that's a clever way to get the list of the alphabet, and things like this seem to come up often enough in these problems that it's useful to have a library handy of formulas like that, char sequence one, or other ways to quickly generate the cell references like you had that you can pull up. Even though it's only 10, you could just type in A to J pretty quick. But if it's, if you got to go A to Z or whatever, so very clever.
Yeah. So yeah, I built this little lookup table with 2 sequences and the char formula. And then going back to it, I could use an X lookup, and I actually used name ranges in this case because I knew that I was going to refer to it a lot. So I called this, I think I called this reference calls, and this reference I called call values, column values. So then I could just X lookup in various ways, and I could just do the calculation quickly. Later on, I actually built a little table from that, or with that same logic. Built it for all the cell references, so that I can actually see that if you wanted to determine going up, down, left, and right, what that would mean numeric sequence wise. Going down is actually adding by 10, going up is deducting 10, and left and right would be 1 and -1. And that way you could easily navigate the maze, especially on the later levels. So setting up like this could actually be beneficial in a live case scenario, because a lot of these cases are different, but a lot of them have a lot of similarities. So your code and your char and your sequences, your lookup tables become important. And then also being able to use arrays like this, you could actually reference back and do your comparisons in that way. So I see that I've broken my level 2 because it used to work. This is because the ones came in there.
Yeah.
But yeah, in the end, that's mostly how to navigate around this. I think this specific one I actually said when it's not 0. So I think it can actually be when it's not 1, and that should maybe solve it, or fix it up again. But yeah, I guess the other difficulty around this is they share the answers with us, but they don't share the solutions necessarily. They don't share how you actually get your answer. But that makes it interesting because everyone has a different way of
well, there's no one right way. Yeah, there's always going to be lots of ways to do it. This question, I'm only sort of looking at it in depth for the first time now, and it reminds me of a previous question from one of the competitions. I forget exactly which competition, but one of the ones that was on early this year might have been a continental battle or something. But so many of the techniques you've just discussed, and sort of navigating north, south, east, or west with movements. So it definitely reminds me of a question I did previously. So it's well worth going over as many past questions as you can to, even if it takes you an hour per one to get through, then you'll have that to refer to if something similar comes up.
Yeah, no, definitely. So I also did this question in 2 different ways. I did it initially with the char and the code, converted firstly to char, then added the number, and then went back to char to get to this one, and then essentially did the lookup with an index match, to check where there's a wall. Initially, I also said, well, this is water and this is wall. Both are treated in the same way. So I replaced every single one of them with a W. And in the end, that worked for me. And I could navigate the clean spaces that way. So my mouse could run successfully all the way through to level 5, and then level 5 came, and it was quite a challenge. So level 5, the challenge was that your mouse should only sort of aim right. So if you are currently in this spot, you would want to firstly go right, which is fine. But next time you would want to go right, you're actually going in the same direction, but you can't go through a wall. So that the mouse turns right again and continues in the same direction. And then because it can go right, it goes right. So it keeps on going right and then goes like that. And then the question is, what is the next cell? So or what is the start and what is the location? And one of my friends actually said that he actually attempted it and realized he's not going to figure out the logic for it, and he just started counting as if he was the mouse. And I tried that myself. You can actually manually solve half of this in 10-15 minutes perhaps, instead of just sitting and trying to find a formula to solve it.
Its strategy is interesting that way, because I find it's worth quickly scanning what each of the 5 levels are before you start, because it might be that the most general solution, which will work for level 5, will also get all the previous levels out, and you could just, if you're confident, work just on that. Or it might be that level 5 has such a rule change that it's fundamentally different, and it needs its own unique thing. And then in case you can skip it and say, well, I'll come to that later, and just work on the other parts. And then, like you say, sometimes, particularly the way this was scored with FlexiQuiz, where you get, questions 1, 2, and 3, and then everything, and you might decide, I can just do 1, 2, and 3 manually, and it's quicker than trying to, accept you're not going to get everything. And so, yeah, there's definitely strategy involved in assessing your limits and abilities and then going for it.
But yeah, an interesting way how I've seen Bo actually attempt this is actually to say, well, you will firstly go in the same direction that you previously traveled in, and then after that you would actually go firstly right, then down, then left, then up. So always clockwise.
Yeah, just that.
So you could,
precedence.
Yeah. So you could actually do a switch. I initially tried this with a switch, and you can also do this with a lookup to check every single cell around the current cell that you are in. So firstly checking right, then checking down, then checking left, then checking up. But firstly checking the same direction that you're going in. And Bo's solution to that is quite magical. But yeah, that's how you'd attempt level 5. So I think that's everything that I wanted to say around the maze question. I don't know if there's anything that you guys want to add before we jump on to the next one.
Not for me. I should probably do the questions.
Fascinating approach. Thanks.
Yeah. So Jason, you want to talk about Diarmuid Early's Othello?
Yeah, sure. Thanks, Renier. I'll take you through the Othello case. Put up my screen. So as Renier was saying, this is a case that was developed by Dim. I understand that he's going to be putting out his own solution video later this week, so that should be interesting to watch how he sort of interpreted it himself and how he would have approached the solution. Again, Renier, you mentioned Bo on Excel Wizard. He did the speed run and has got some crazy formulas there. So if you want to see an extensive let formula, I encourage you to watch that video. I'm not going to attempt to unpack that formula in this session, but I'll take you through sort of what, how I approached the question and, having given it some thought, what I would have done differently. I got to the end of level 3 within the 30 minutes on Saturday. And then I've sort of been playing around with level 4 and 5 to try and come up with an approach that I would have followed, in terms of my own sort of logic. So maybe just to paint a picture of what the case is. It's called Othello. It's a board game. Essentially, you start out with 4 checkers, 2 black and 2 white, and you can put down a piece if it's your turn. So if it's white's turn, for example, you can put down a piece that captures a black piece, and you can capture a black piece if when you put your next checker down, there's a black piece or a number of black pieces in between the checker you're putting down and the next white piece, one of your other pieces. So as an example, you can put down a checker here, and that would essentially capture this black piece and turn it to white. You could put it here, and that would then capture, vertically down. But you can't place a piece in C3 as an example, because diagonally there's no white piece to sort of end the chain. So there's got to be a chain of 2 white pieces on the ends and then black pieces in the middle. And it doesn't really matter how many black pieces there are in the middle, but as long as you can create a chain with that sort of general characteristic, then you can place your piece. And we were given a bit more extensive example just to demonstrate that. So in cell A1, you can't place a white piece because looking vertically down, there's no white piece at the end of this black chain. Looking to the right, there is no other piece to the right, so there has to be something directly next to you, and sort of vertically down, there's a white piece next, so that you can't complete the chain. There's no black piece next to you, adjacent to you to start the chain. Whereas in cell B1, there is a vertical play here because the piece adjacent to you is black, and then there's a white piece to end the chain. And you can also play horizontally across because of the black and white piece in that chain there. So that's the general rules of the game. The first question, count how many pieces there are on the board. So this board layout, which is, I guess, similar in layout to a chessboard, pieces, columns A to H and rows 1 to 8. This whole board was sort of unraveled into one long chain, 8 by 8, so 64 columns, and then showing us what the pieces are on each of those squares. The first level was just count how many pieces there are on the board. So the approach that I took was just to do what-ifs of the white pieces and the black pieces and sum them together, which seemed fairly intuitive to me at the time. Watching the solution, which I thought was really genius, he did a sum-ifs on the range. If there's he just used a wild card. What about that? Sum-ifs, sorry, sum range criteria. So criteria range, and then he just used a wild card. I think I've done that right. He used the wild card.
I think we lost Jason. Yeah. It seems like his connection was a bit broken for some reason. Oh, he's back.
Coming back now. Yeah.
Let's see. He's probably just going to join. There we go. Jason, you back? I see you muted. Just unmute yourself. Yes, it just seems like your connection is a bit unstable for some reason.
Hey, can you hear me?
We can hear you fine, yeah.
Can you kill the kind of video? Can you hear me okay now?
Yeah, you sound fine.
Okay.
But your video's still there.
Okay. It's not load shedding this time. So
yeah, we got a comment in the YouTube chat asking if it's load shedding.
I'm gonna carry on in the interest of time while the things work.
Yeah. Cool.
So my initial approach with the count ifs white and black then sort of helped me in the next question, which is just count the number of black pieces on the board. So just look at the black pieces and just pick up the black square. So that actually I just transferred and took out the white piece, which worked pretty well. So these two levels were fairly easy. Level 3 was if you're given a board and a specific cell, can white play a valid move? Now, so I managed to get through level 1 and level 2 reasonably quickly. But level 3, I was sort of struggling to unwind the board in my mind, given this chain. And I think the main, sorry, I haven't shared my screen again.
You want to share? You're welcome to share.
Yeah, sorry about that. That it wasn't sharing when I reconnect. Do you mind if I just take a video?
Go for it.
Apologies. So yeah, level 3. Because you're given the board in this sort of just a string of cell values, I really struggled to
I think we lost his sound again.
Yeah.
Can you guys hear me okay?
You're
Yeah, it
coming in
seems
and
like-
out, Jason.
It seems like
Okay.
every time you share your screen, it breaks.
Okay. Renier, maybe do you want to perhaps
Yeah, I'll share. I'll share
and then
screen
we-
and you go. Yeah, you just talk.
Yeah, sure. So perhaps just put on level 3. Yeah. So I think, you know, given that the board was laid out sort of A1, B1, C1, and then A2, B2, you know, to try and think about how I unwound that board, I think took me more time than was worth in the session. And I actually ended up doing, funny enough, you mentioned on the previous case that, you know, you could have done the case, the level manually in about 10 minutes. And I actually just reverted to doing that for level 3 on the day. I just went and did, you know, question 31 to what was it, question 50 manually. So I set up an index formula that let me recreate the board in its 8x8 layout, and then showed me which cell was the cell that I was being given, and just manually went and entered that. And I seem to get all them right, although I didn't get the point, so maybe I put in the total incorrectly on the day. But that approach actually seemed to work for me. But then, sort of having given it some thought after the fact, and then specifically, if you just scroll down to level 4, so on level 4, you sort of given the same layout. What, you know, you're given the board layout and you're given a cell that you're going to play in. The question is, assuming you can play, and in this level 4, all the moves that are given are valid moves. Assuming you can play, how many pieces do you actually capture when you play that move? So this one I've been thinking about and trying to resolve. And in my mind, you know, I converted all the black checkers into 1s and all the white checkers into 0s, and that gave me a string of 1s and 0s if I looked up or down or left or right, or diagonal up, diagonal down, you know, left and right respectively. So there's sort of, I guess, 8 directions you can look in from any given square. Obviously, if you're on the edge of the board, then there's just nothing to the, you know, outside the board. But if you look at those 8 in those 8 directions, you get a string of 1s and 0s, and then possibly a space in, you know, somewhere in between. And then using so first thing to check is the value in the first value in the string, is that a 1? So is it a black? Because you remember, you're playing white, then the next checker in the string needs to be a black one for you to have a valid move that will capture pieces.
Yeah.
So the question is that value a 1? If it is a 1, that's great. And then the next check is, you know, is there then a white one that comes somewhere down the line after that? And then you need to count the 1s in between. So I actually found that using the text before and text after functions, text before the 0, assuming there is a 1 to start with, how many 1s are there? And just looking at the length of that string of 1s and 0s gave me the number of black cells before the next white cell in all directions. And then you just sum up that row. And that gave me the answers for level 4. So I thought that was in my mind a fairly neat solution. Although I must admit, it did take me some time to set up the formulas that look in all 8 directions. So I'm not sure that I would have been able to do that in 30 minutes. I don't think I would have been able to come up with that. I mean, you know, to come up with the logic of doing it that way. But I found that converting the blacks and whites to 1s and 0s, and then looking at almost like a binary string of numbers worked quite well. And then I think for level 5, you know, it takes it to the next level, and so, you know, sort of similar layout. The question is, what is the best move that captures the most pieces? And this question is something I haven't sort of come up with a solution to in terms of how you test all of the open squares on the board. And I guess you could take my logic from level 4 and then cycle it through all of the empty cells that are available, and then pick up where the maximum one was using a data table. That's sort of in my mind what the approach would need to be. But you know, be very curious to see how Diarmuid sort of suggests solving that from you know, having created the case.
Yeah, and like you said, Dim is sharing on his YouTube channel. He's sharing how he's completing all of these cases. So if anyone wants to see a deep dive and a live case, or even a speed run, you can go and between Diarmuid Early and Excel Wizard on YouTube, you'll be able to find all your answers to these cases. But Joe, it's interesting what you're saying, Jason, and what's interesting is you could actually, in a scenario like this, you could actually, if ones and zeros work better for you, you can just go and do a find and replace across all of them, and just go and replace all the black dots with ones and all the white dots with zeros, and then you can work from there. And in a lot of cases, it's just easier when it works like that.
Yeah, agreed. That's exactly what I did. Just did a find and replace on the whites and blacks respectively. And I find as a general rule for these tasks, you know, converting the symbols into something usable is often quite helpful.
Yeah, and I mean, when it comes to a difficult level like this, I just jump. In a lot of cases, I just jump into a data table from the get-go, and I just go in and do a transpose, index or XLOOKUP, and I look up my value in my task. I've actually been in the answers, but look it up in the task list, and return the complete sort of block of information, and that immediately gives you the board that you can play with. And in this case, you could actually use something like, I mean, if we actually go and paste transpose the pieces like this over here, like that, then you could rebuild the board with potentially a wrap rows or a wrap cols. I'm never sure if it should be a wrap rows or what it should be, but I think it's 8. Let's just see what it looks like. So that, I don't know if is that the right way. So that means you could apply the same logic with wrap rows over there on the spilled range, and do that like that, and you've got your block. And if you had replaced all of these dots with ones and zeros, then you'd be faced with ones and zeros in this block, and then from there you could follow your logic. And it just, once you have a picture, I find it's just easier to make sense of it.
Yeah,
all right.
Absolutely. I mean, to me, this is how I solved the third case manually, right? I just literally put this in a picture for myself, figured out what the starting block was, and just counted, you know, to see if it worked. But just visualizing it to me made it a bit easier to interpret. For the guys that can work with the data in the string, you know, it's amazing to me. But the wrap rows and wrap columns here is a game changer, right? It is to do this, and is a big driver for why you know, it's beneficial to use my home computer, which is on the sort of monthly channel, versus my work computer, which is on the semi-annual channel, because we don't have the latest you know, text functions yet. So the text before and the wrap rows or wrap columns in this example are really game changers to working quickly. So
and even formulas like take and choose calls and all those new formulas are absolutely amazing with the power it gives you. Okay. Does that cover Othello for you? Are you happy?
Yeah, thanks.
So maybe we can jump into the next case, which would be the social network, if I'm not mistaken.
Yes.
Right, Dan, you want to maybe intro us to the social network? You want to share your screen, or how do you want to
sure, I can do that. Where are we? It looks like the one. Okay, so this piece here, those that don't see it, there are 50 people, and you got a cross table here that basically says whether they're friends with each other or not, which is the little blue icon, and the yellow just means they're close friends, and some of the questions treat close friends differently than friends. This is, of course, a sort of a symmetrical matrix along the long diagonal, because if Betty is friends with Aaron, and then Aaron has to be friends with Betty. So much like Othello or the maze one, it's often useful just to turn this into sort of ones and zeros, or ones, twos and zeros, if we want to distinguish between the two types of friends. And so it's also, well, I guess if we quickly skim the questions and we see sort of what we're being asked, take 2 minutes to plan a plan of attack, and then you can see how you go. So the first thing I did was, converted this whole table into a little 50 by 50, and I haven't labeled it because this was the actual one I was doing on the fly. 0 if there's no connection, 1 or 3 if there's a start connection. And I'm sure there was a reason I used 3 instead of 1, and I think it's because
the 3 is the bonus. The bonus
question.
I
think it was because I read this up here. If each close friendship counts as 3 normal friendships, who has the most friendships? And that bonus one and then level 5 were the only things that distinguish between close and regular.
Right.
So I made that version first, and then I made a second version that treated all the close friends as just a 1. So here this table, there's no distinction between them. And with that, it was, that gave me the building blocks. And so if we look through, case how many friends do the following people have? The names were all alphabetically ordered, which makes using a match function with approximate matches work, but we can stick to exact matches anyway. And so like the first thing I did was I got sort of the sum of counting it with the 3, which got me the bonus and the count as well. And then here, what did I do? So I actually just wrote the formula and the answer here, where I'm just looking up how many friends do the following people have. Well, I'm looking at my row 58, and which part of that row, well, wherever the name matched. I'm a big fan of index match. Row 58 was just the count, and so that, whether it's a 1 or a 3, they both count 1 because I'm just counting greater than 0. So that's level 1 done very easily. Level 2, it's much the same here. We're just looking for kind of the earliest location of their name. So here I've got row 113, and see there I've actually put in row 113 a little match function that looks for where does number 1 first occur, knowing that a match with an exact match with it 0 1 0 0 1 1 1, that's going to return first occurrence of the 1. So here Aaron, his first friend is the 3rd name in the list, and so then that's what this is doing. This is pulling out the 3 for wherever, in which column, well, wins column, and then that's gives it in the format we wanted. If we converted these numbers back to names, we'd get the name of the first friend in the list, but that's not what the question asked. So levels 1 and 2 were pretty simple there. Levels 3 and 4 I found very, very similar to each other. Thinking about how to approach it, just using this table, which is rows and my panes across the top. So this is a column for, say, Charlotte, saying, she's not friends with any of the first 11 people. She is with the 12, 13, 14, and so on. And so if we go down to level 3, this is just a selector 1 through 20 to pick the case. a couple of index functions to return, basically, for whatever case is selected, 1 through 20, return these two names. Convert those to, you know, where they are in the list of names, the 15th and the 20th. So then I pull the 15th column of that matrix we had up the top, the 20th column of that matrix we had up the top. And the only trick here is knowing that, I mean, it's a lot easier with dynamic arrays now, but if you have an index on a two-dimensional range and you give one of the either column or row parameters a 0, that means return every column, or in this case, every row. So yeah, that's every row, and then the 15th column of my matrix, that's all of Harley's friends, all of Johnny's. Level 3 basically then wants to know how many times both of these are 1. So we can just multiply the two together, sum them up, and that's our answer for level 3 for this first question. Put that in the data table. There's all the answers for level 3. Level 4 is identical, except instead of this being, you know, A times B, it'll be the maximum of A and B. You basically want to return a 1 when either of these are 1. You could use also an AND function for level 3 or an OR function for level 4. We just did it with the times and the max. Otherwise, level 3 and 4 are identical. So that was all very, very quick. And I got all those out pretty quickly. Level 5 was a little bit trickier. And so now we distinguish between the close friendships and the regular friendships. So here, the question, you sort of want to know how many people in total are either my friend or a friend of one of my close friends. Without double counting. And so I thought about this, and my approach was, well, first I identified that the maximum number of close friends anyone had was 6. And I just looked at the data for that, found it was 6. And so then I set up a solution that would kind of work for 6 people. And if we picked a more interesting case like Victor. So this returns the, I guess, the index number of all of Victor's close friends. Sorry, that's Victor itself is the 42nd name on the list. And then here I'm looking for where is a 3 in, so this is Victor's column of friends from the first matrix where it had 1s and 3s for regular and close. Where's the, and I'm sure there's a better way to get all the locations of the 3s. So there's a 3 at the 5th spot, there's a 3 at the 22nd spot, and there's no more 3s. But I just said, well, where's the first 3 in the whole thing? And then where's the first 3, but in a kind of a filtered list. And so what this whole long thing here is actually looking at is the range that's in blue here, but starting after location 5. So starting at location 6. And yeah, that's just, and then the next one, if we have someone with 3 close friends, this would then start after location 24. And I've just realized what error I've made, and it explains why I got some of the level 5 answers wrong. And it was basically this, that should just be that. And now I'm sure all my level 5 answers were correct. It turns out I actually got 11 of the 30 level 5 cases wrong. And now I know why. It was just that one little typo in that formula that Ian was laughing. I can see him. Yeah, and so that
happens to all of us, Dan.
Yeah, I know. It happens to me a lot in these. I mean, I still got through, but I got a very odd looking score. Yeah, and so then once you've got a list of, now I know that the post is going to be shared with basically any time of the 50 people. Any of these are a 1 or a 3, or basically there's something non-zero across any of this, it'll get shared. And so that and there's the level 5 answers. And I'm sure if I go and copy and paste these over here, you can see all these flags. Was I right? Now probably will. Okay, no, still didn't quite work. Oh, maybe I didn't refresh the data tab. Anyway, whatever it was, I'll debug that later. that was my broad approach.
So what's interesting to me, Dan, and welcome, Dim. Welcome for joining us. I know that you said you've got a terribly busy week, but thank you for making the time to actually join us on the session.
No, happy to make it. Sorry, I'm a little late.
No, it's cool. I saw your solution on this, and you actually had a much different approach, and that's the amazing thing about these cases. I actually spent a lot of time just to make sure that how would I approach it before I watch your attempt, Tim, and before I watch Bo's attempt. And every time there's a different attempt, and you mostly did filters throughout the whole thing. You actually used the filter, and you drew a status. But I actually saw that you were a little bit flustered in the beginning of the question in how you set it up. And I think if you did it again, you would do it much differently. I guess you would have gone for a 1 and a 3 as well, like Dan did. And I think that's just experience where Dan just read and he saw there's a 3 on close friends, and he went for a 1 and a 3 immediately, and changing all of them to numbers instead of the icons made a lot of things more simple. And I see that Harry's actually on the chat as well. So Harry, who's the case author, actually joined on the live feed as well. But you also said that Harry had an interesting way to attempt. Was it the bonus questions or question 5?
Yeah, was it the last bonus question? I think you can use it for level 5 as well. But yeah, so basically, if you think of that kind of matrix as Dan did in his example, with just forget the distinction between friends and close friends, just make it all 1s if there's a connection and 0 if there's not. So you can think of a row of that matrix as how many ways are there to get from the person in this row to the person in this column in one connection. The sort of cool thing is that if you then multiply that matrix by itself 2 or 3 or more times, what you end up with is the number of ways to get from a person in the row to a person in the column, not in 1 step, but in 2 steps or 3 steps or some other number of steps. It's just, it just sort of parallels the way that matrix multiplication works. It's, if there is 2 ways to get from A to B and 3 ways to get from B to C, then you end up with 6 ways to get from A to C in the matrix that you get by multiplying them together. And so if you multiply the matrix by itself 3 times, you end up with, here's all the ways to get from one person to another person in 3 moves. And then basically, if you kind of sum up the main diagonal of that matrix, all the ways to get from each person to themselves, each triangle adds 6 to that, because there's basically, each person has 2 paths out to somebody else and back to themselves for each triangle that they're in. You can either go one way or go the other way. And that triangle has 3 different people. So each one contributes 6. So you basically multiply that matrix by itself twice, sum up the main diagonal, divide by 6, and that's it. Like, you can literally do it in a 1-line formula that you could type out in probably 30 seconds if you knew what you were doing. It's funny. I sent Harry a message the other day after I did the case to say, really enjoyed it, nice work. And he sent me a message back saying, did you spot the quick way to do the last bonus question? And I wasn't smart enough to figure it out, but when he said the quick way, I thought to myself, well, I used Power Query when I went back to try it again later to, figure out why I had gone wrong. And that's kind of fast, but it's not so fast that I think he'd be. And so I wrote back, does this have something to do with matrix multiplication? And he said, yes, it does.
Yeah, it's interesting.
That was a very cool trick. And you can use it as well. Like, if you take a matrix, just with 1s for the close friends and multiply that by, 1 with 1 for any connection, you can use that to work on level 5 as well. I think you can do one of the other bonus questions with it. It's like, there's some very sort of deep stuff going on there between the network matrix and the kind of
it's a good trick. And granted, you need a bit of a mathematical and linear algebra background to know that it could work. But yeah, like you, Dimit, I'm well familiar with the maths, but I didn't spot it at the time. And then when you sent me a note saying, the matrix solution's a genius if you replace. And at that point, I was sort of like, yeah. And then I saw it, without even reading the rest of the explanation. But I've used similar tricks to solve other questions, but it didn't occur to me to do it this way. for this one. Yeah.
It makes me think of six degrees of separation, permutations of 6 degrees of separation or something. But I mean, it's interesting. It's interesting that you can this is a small example, but you can actually apply it to a much larger problem using matrix multiplication.
Yeah, for sure. It was funny. I was thinking about it afterwards. Like, if this was like an hour question rather than a half hour, what other questions could you ask? What clusters are there and that kind of thing. It's such a rich. It's like the data is so simple, but there's so much that so many questions you could ask about it.
Yeah.
Yeah.
In the interest of time, I think we should jump to the last question, which was the one by Willem Gerritsen.
Oh, Willem. Yeah.
Willem Gerritsen. I know that Dan, you've got an interesting.
I'll take the lead, and I'll talk about Diarmaid's as well, and he can jump in because I certainly watched his video showing his solution. So this one, code and char, that the functions are your friends, and if you don't know those, this is going to take you a lot longer. If you do know them, it's great. I actually sort of redid part of my solution this morning just to make it a bit more fleshed out and easier to explain. But when I got this case, and because I was actually on the live stream, I got the case about 5 minutes before we could start working on it. Now, we weren't allowed to work, but we were allowed to look at it, and I could think about my approach and write down on pen and paper. And during that 5 minutes, I basically came up with sort of the algorithm that says, well, once you've got a letter, starting with just the lowercase letters, and I know the lowercase letters in ASCII code range from 97 up to 122. And if you're not sure about that, you can just go, code A, and you'll see 97, and the same with Z, 122. So it was just a case of use the code function, subtract 96 would give me a number 1 through 26 for what letter it was. I could apply the shift then using modular arithmetic. And so if you go into the negatives, you just sort of start again at 26, and like as if it was a circle and you're going anti-clockwise around the circle. And then turn it back to the letter with the char function after you add 96 again. So, it's kind of code, subtract 96, apply the shift in modular arithmetic, and then add 96 back and use the char function. And the only thing to watch out for with applying the shift was with the mod function, mod will treat a Z, as 0 when you want it to return 26, because the mod function's going to return between 0 and 25 when you want it to return between 1 and 26. So there's probably a more efficient way to do this, but that's why I put the if in there. And for some reason, I added a large multiple of 26 because, I don't know, negative numbers were potentially causing an issue, or it might have been that 0 thing. I don't recall at this point. So that's just, level 1. And level 2 is exactly the same thing. It's just you need to break out the word into the individual letters. And so while Diarmaid essentially is the same approach, but he did it with array functions all in single cells, I wanted to give myself the space to, do it kind of letter by letter, even though these are just the same formula dragged down. These are all dynamic array things. And then the data table, like I explained for the previous case, to get them all. So I just went with much the same setup, an input selector there. The data table can use index to grab what's the word, what's the delta, the sequence of the length of it, and then a mid on that to break it down letter by letter. There's probably other ways with the new dynamic array text functions to get it out letter by letter, but I know this works. And then exactly the same algorithm as before. Here I've just put the last two steps together, concat to get it. And so there's level 2 done. This one was also one where levels 3, 4, and 5, even level 2, 3, 4, and 5 could have all used the same algorithm. The algorithm I wrote for level 3 would also work for level 2. The algorithm I wrote for level 5 would also work for level 4. And the only difference between the level 3 and the level 5 algorithm is if you increase the shift multiplier or not. And so here I've just put one together And I just, for the sake of this illustration, so level 3, 4, and 5 will all work, even though it says level 5 there. And just a little, chooser here for what level we're doing. And all that chooser does is changes what reference the index looks up to grab the word and the shift from sort of case 1 through 30 for the level. And then it also treats the shift multiplier differently. When level 3 is on, you can see the multiplier is always 1. Whereas if, say, level 5 is on, then the multiplier will increase whenever we have a regular letter and not a special character.
Funny thing is, if it was anyone other than you, Dan, I would say, oh yeah, obviously you've kind of cleaned this up after the fact. But I saw you on the live stream, and your worksheet was just as crisply formatted under time pressure as ever.
This particular tab is the worksheet from the live stream, and I've just added this part this morning. But it was that. I brought in some pre-formatted custom styles before I started, just so I had them there, which is where I can get these formats easy. But otherwise, the only thing different was where I had 96 as hard-coded before for the lowercase letters. Now, sometimes I'm going to want a 64 because the capital letters run from 65 up to 90. Sometimes I want 64 instead of 96. Sometimes I want 0 for the special characters. So I added kind of, what's the code of the letter? And then I can use that code. Is it between 65 and 90? It's going to be upper. Is it between 97 and 122? It's going to be lower. Otherwise, it's going to be special. And then those binary flags kind of then just help me. This one is used to increase the shift multiplier or not, as well as then the formula where once we're done and we have to kind of add back either the 64 or the 96, it uses those again. And knowing that you're only ever going to have one and exactly one of these being one, I can just use the sum product function across there and these to determine, do I want to add or subtract 64, 96, or 0? Otherwise, it's the same approach. This one, some of the functions weren't working with the dynamic arrays with, the hash reference, so I actually just built it out to the maximum length of a level 5 string, which was 177. And if, added a condition sometimes of, is the sequence, which works on the length. If that's bigger than, or if that's 0, then, ignore stuff. And that just means we don't have to deal with the value errors. But at the end, you can see here, my horror at his crime, blah, blah, blah. And we can cut that. And then there's all the answers. And this one algorithm will work for all of them, and it would have worked for level 2 if I put level 2 in here. It would have worked for level 1, actually. They all just would have been one thing string. So this was one, if you look at, you could see, okay, I know if I write a general thing for level 5 and I just have a switch for increasing the shift multiplier or not for level 4 and 5 as a switch, then one algorithm will do all 5 levels. And if you're confident you can do that in the 30 minutes, you could just go straight for that. This was one where, for anyone watching the live stream, I actually got out in about 22 minutes, except when I was trying to calculate my data table for level 5, and I had levels 3, 4, and 5 sort of done separately. I just overwrote the previous work. When I was trying to do the data table for level 5, my Excel just shut down. So I never ended up getting the points for level 5. I tried to then rebuild it in the last 8 minutes, and I ran out of time by about 20 seconds. So not for that, I would have joined Dim on a perfect score on this round, although he would have done it a few minutes quicker than I did. But yeah, this was a fun one. And as I said, Dim can talk about his, but I watched his video, and it was a very, very similar approach. He just being a bit more comfortable with, lambdas and, takes and whatnot, just in scan, just decided because he could, I guess, do it all in a single cell per word. But I don't know. I find for me, I assessed, okay, I could use helper cells like this. I could still do it in time, and it's certainly going to be easier to debug if I happen to get something wrong along the way.
and I guess you summed it up perfectly there, Dan. And while you were showing your solution, the magic in your solution lies in the fact that it's so simplistic. Actually, you've taken something overly complex, or not overly complex. You've taken something complex and you've made it very simple, just by breaking it up properly. And in a lot of cases, with a lot of experience, if you need to quickly solve a problem, that's the way to go. And I mean, watching your video on I think on this, the social network, Harry's problem, there I saw you also breaking it up and then putting it back together. But I mean, I see that Harry in the comments said he used a little lookup table instead of using char encode. And I actually did the same in the end, because then you don't need to necessarily treat the special characters in a special way. With an X lookup, if you don't get a match, you treat it as a space and you go on, right? So
there's no one right away.
It's
just when I read the case, the first thing that jumped in my head was char encode, and the things I'm quite familiar with, because actually a few years ago, I tried to put together a little sort of Excel education model on the text string functions and included char encode, and so they were in my head, and that's where my brain went. But lookup tables, you need an easy way to convert between letters and numbers, and A through Z being 1 through 26, and a lookup table would do the trick as well.
Yeah, I mean, char encode with a mod, and you've got everything sorted, because you can manage between the 26 letters, uppercase and lowercase. But then if you know char encode but you don't know mod, or you don't know how to apply mod, then you go back to lookup table. So in a lot of cases, I've seen doing a lot of these questions, just in a lot of cases, just do a lookup table. When it comes to like working under pressure, trying to figure out why is my mod not working, reverting back to a lookup table.
It's definitely using what you know helps. I mean, you saw I didn't use an X lookup or really lookup anywhere, but that's because I'm very comfortable with index match, and I know that under pressure I can get that out error free quite quickly. But that's just me. But generally speaking, having a good knowledge of the different functions helps. And so anytime Excel releases new functions, it's worth trying to learn what they are, practice a few things so you become familiar with them, and then they're added to your toolkit, and your brain will be quicker to know, this will be the right function for the job here, when you see it.
But I mean, I totally agree with what both of you guys said. Like, I think using what you are comfortable with, especially in the context of thinking about, 30-minute quit, like if you're sitting for a day to work on something, in your job, then it's worth spending a non-trivial portion of that day thinking about what's the best design, and are there other functions I could be using, and are there other ways to build it or whatever. But, like having a good design is really important in a question like this, but at the same time, you can't afford to spend 10 minutes scratching your head and thinking about the design. And so, like, I mentioned on my social network video, I think I did not take the right approach to that. I unwrapped the network graph into a big table. And then multiple times as I was going through it, I was like, this probably wasn't the best. And sure enough, I saw other people's solutions afterwards that just worked with the graph. But it's, I'm so used to the idea that if you have something in a grid like that, well, Excel is better for tables, so I'll unwrap it right away. And, it's probably like if I had spent a bunch of time, hey, this is starting to not work well, maybe I should, like, you lose too much time going back, starting a new approach. You just have to go with something and commit. So it's better to go with something that and you have a sense of, and you have a sense of where you can get to with it. Yeah,
true. So you develop an exam technique, and I mean, in a lot of cases, you say in live videos, especially, them you go, that ship has sailed. You just say, the ship has sailed. We're sticking to this method, and that's how you should do it. Don't redevelop and don't redesign in the middle of your case. If you need to do that, rather try and solve it manually or something like that. And I mean, I spoke to one of the college students that I'm mentoring as part of the collegiate challenge, and and I mean, we spoke about exam technique and how Jason and I learned exam technique at university. We actually learned you take your time, and you've got 1.5 minutes per point. So multiply the number of points by, and that's how much time you spend. But with modeling, in a lot of cases, you get 0 if you don't have the answer, or you get 100% if you apply your data table. So in some cases, you need to know, you need to develop that feeling of, what's my method that I'm going to apply? Am I going to build a data table? Do I spend the time to take this out to a different sheet? And do I spend more time than I need to, or do I move on to the next question, or onto the bonus questions even? Because the bonus questions actually, that's a new thing that they've introduced now.
Sometimes it's a separate piece that you could do it. And I mean, from a question design point of view, I know I was always cognizant of not trying to have all or nothing questions where you either got 0 or 100%, because it's very hard to differentiate people that way. And, you know, when Andrew started up the FNWC, I had a long session with him talking to him about question design and some of the lessons we've learned from Model Off. And, you know, that's why you'll often see these questions written progressively in parts, both where you can get partial marks as you go along, and hopefully you can self-assess with the way the multiple choice answers are there to know if you're right prior to going to the next step, you know. And that's just that just makes for better competition in this format. But yeah, in a real world modeling problem, and in some of these, you're right, is just kind of, it's all or nothing, and so you got to just try to get it right and take the time needed to do that.
Yeah, I'd add one other thing there, which is, you know, I think especially in this group, we're pretty used to, you know, like my working assumption tends to be I should be able to build a full solution, and so let's just kind of try and go at that. And you know, Renier mentioned, like, at some point maybe you want to just start going through it manually. I think there's also a middle ground, which is, depending on the question, you might be able to identify, you know, a subgroup of a level that would be easier to answer. So like a couple of examples that come to mind on the last level of the social network, if you identified people who had no close friends, then it would be pretty easy to figure out how many people saw their post, because it's just their friends.
Yeah.
And, you know, that might give you, I don't know, 30% of the answers or something like that. Or like on the Othello one, you know, one of the ways in which a move could be invalid was you're playing on top of a piece that already exists. It's like, well, those ones are pretty easy to spot right away. Whereas, you know, splitting the ones where there is an open space between you can and you can't play is much harder. And so, you know, if you find yourself like, okay, I've got 3 minutes left, I can't build a full model for this. You know, sometimes it will just be the fastest thing you can do is just do them manually, and you can knock out a few. But sometimes you'll be able to say, maybe there's a smart way to figure out what are the easiest ones of these, or the easiest type of these to tackle.
And I mean, Diarmaid, you and I were discussing this yesterday with the cipher question, the passing notes, that particularly with the flexi quiz multiple choices, sometimes you only have to just solve one letter from a question, and then you would know, okay, well, the third letter in all of the flexi quiz multiple choices is different. So if I can just solve the third letter and match it up with something in the multiple choice, I can get that, you know. And so if you don't have time to do the whole thing, or to figure out how to, you know, cipher a whole word, just pull out one letter and then just cipher that, and you can sometimes get the answers. Just gaming the information available, you know.
Yeah, those are good tips. So yeah, I'm excited. We actually rushed into this live session because the next round is tomorrow. So both yourself, Dan, and Dim, you guys are both.
We're actually slated to meet in the second question tomorrow. So I'm assuming we both get through the first question. So I might have to.
Well, I didn't make it past round 3 last year, so I'm not assuming anything.
I might have to, I don't know, like phone Dim's wife and get an emergency going in his house or something.
You guys are both in the afternoon session, right?
Yes, we are.
That's right.
Yeah, we've got a friend in the morning session who's in the live stream. Stein, good luck for you, and then for the two of you, good luck on the top 32 and top 16 rounds. Hope it all goes well, and We'll be watching. Unfortunately, yours won't be live streamed, but we'll be watching the brackets. And yeah, good luck, and I hope all the best.
I'm sure
I hope you
Dimit
guys
will
make
record
it.
his and post it later. So
Yeah,
Yeah,
I'm looking
look forward
forward.
to the
I'm looking
recording.
forward to
Probably,
that.
unless I
Yeah.
blow it.
No, yeah, but thanks so much for everyone's time. Thanks for taking out the time. I know Dan waking up really early in the morning and Dim in a very tough week. And thanks Jason
That's
for
okay.
for a late night. Appreciate it.
I mean, there's a whole bunch of Champions League football games that just started, so I could, tune into those now while I'm up.
Enjoy, and yeah, we'll chat again soon in the next after the next round. And yeah, good luck
Thanks
out
for
there.
having me. Pleasure.
Thanks Dan. Thanks Dim. Thanks
Good luck,
Jason.
guys.
Thanks, Renier. Take care.
Goodbye. Okay, so we are not live anymore.